The Ensemble interface is split into two parts. On the left hand side we see an overview of the ensemble, listing all configurations and all available values of cooling. On the right hand side we have a table showing minima and maxima in the topological charge density field labelled Q and Wilson action labelled S. User is able to look through these to find minima and maxima in the respective fields. Graphs of the cooling process can steer the user towards interesting configurations. In particular, the peak Wilson action can help to identify merging of instantons or objects falling through the lattice. Also available to the user are graphs of topological charge density. The total gives a rough estimate of the number of objects on the lattice, whilst the peak rough estimate of size. Using feedback from the graphs and estimates of maxima, the user can select multiple configurations for generation. Common visualization series such as cooling or multiple configurations can be quickly selected. The selected fields are generated in parallel. The main user interface is split into three parts, showing a flexible isosurface view of log data along with its contour tree and Reeb graph representations. Objects spanning a periodic boundary can be highlighted by the user and observed in the Reeb graph and contour tree. To allow the user to understand the contour tree and Reeb graph views better, they can be embedded in the rendered volume. The user is also able to interact with the graphs to prevent occlusion by moving the nodes. The user can choose to vary the ISO value directly. Alternatively, contours can be displayed as a user-specified number of layers. As the number of layers are increased, additional structure is revealed. Individual topological objects can be selected by the user. It is possible to hide objects to reveal structures of interest, such as potential instantons. Instantons are typically characterized as global minima and maxima in 4D space-time. Many fields in lattice QCD, such as the space-like and time-like plaquette fields, are linked. In order to understand interaction between fields, they can be viewed in parallel. This is also useful for sliced 4D data, where the same object can be viewed from different points of view in parallel. ISO values and camera rotations can be applied globally or limited to a single view. When viewing topological objects from different points of view in 4 dimensions, it can be useful to consult the orthogonal data views to determine locations. This can be cross-referenced to values in the Ensemble module to validate the presence of instantons. The user can view the cooling process by stepping through the data. The topological graphs update with the rendered view. It is also possible to move through 4-dimensional slices of data. We also allow the users to view bivariate topology using a quantized approach. The user is able to vary the level of quantization. We show a view of the two input fields at the specified interval, along with the bivariate view of the data.